Alright, let's jump in with number 9. We've got another quadratic here that we'd like to solve, but it's not written in standard form. So we need to move everything to one side, and so what that looks like is subtracting 9x and adding 18 to both sides, so that those will cancel out, and we'll end up with x squared minus 9x plus 18 is equal to 0. Okay, this looks factorable. Are there factors of 18 that add up to -9? There are indeed. -6 and -3. So we get x minus 6 times x minus 3, and that's equal to 0. So I have two very real solutions on this one, x equals 3 and x equals 6. And we can check that one, and that's true. Okay, so we could solve that with any method, but again, the reason we teach you all these methods is so that you can come to a problem like this and immediately look for the best way to solve it. Okay, number 11, notice it doesn't ask us to solve it, it asks us to use the discriminant to determine the number and type of solutions. So, are there real solutions? Are there non-real solutions? Is there one solution to this quadratic with multiplicity? So do we have something where it, maybe comes up like this and just touches the x-axis, okay? So just remember, if b squared minus 4ac is equal to 0, that's one real solution. If it's greater than 0, that's two real solutions, real distinct solutions. I guess one real distinct, okay? So it still has two solutions. It's the same number, though. It could be like x minus 2 squared, so x equals 2, and x equals 2 would be the solutions for something like this. All right, and then if it's less than 0, you have two non-real solutions, because that part of the quadratic formula is under the square root sign, and so if you take the square root of a negative number, what do you get? You get I, and you get non-real solutions. Okay, so let's do it. B squared. 6 squared minus 4 times a, -8, times c, which is -9. Okay, so I get 36, and then I see a negative times a negative, which is a positive, times another negative, which is a negative. And that's going to be a big number, so I'm going to imagine that it's going to be a negative number. Let's find out what it is. 32 times 9, 27, 288, no, 287, no, 288. Alright, and that's equal to -252. Alright, so I'm going to go here and say two non-real solutions. Is that what the discriminant is? Yeah, -252. Two imaginary solutions, two non-real solutions, same thing. Okay, so what this means is this function never crosses the x-axis, but that the fundamental theorem of algebra says that it still has two solutions, they're just non-real. Whoops. Alright, let's go to this one. Spoiler alert. On this one we have a couple options, but one of them would be just to divide this whole thing by 4. But remember, that doesn't change our zeros, and it doesn't change the type of solutions we have. So we could end up with n squared plus 2n plus 1 is equal to 0. And that just makes our discriminant smaller and easier to work with. Okay, so we could do that over here, and we'd get b squared is 4 minus 4 times a times c, and that's equal to 0. So we have one real solution. Okay, and now let me try to prove that that's actually the same as if we had used the original equation. So b squared would be 64 minus 4 times 4 times 4, which is also equal to 0. And so we'd have one real solution. Whoopsie. I need to move this, huh? Okay, so let's jump now to number 15, which says to factor this cubic by grouping. It's nice when things group, huh? So we group the first term with the last, or the middle two terms with the last, no. we group the first two terms with the last two terms like this and this. Okay, so let's do what can we factor out? We can factor out an m squared and leave 3m minus 1. Okay, and we know that if we factor it out of one group, we want to factor it out of the other one. So we need a 3m minus 1 there. Okay, and what do I multiply by 3m to get to negative 9m? That would be a negative 3. And then my last step on this is always to check and make sure that I can actually factor it by grouping. So if I multiplied negative 3 by negative 1, I would get the positive 3. And so yes, this factors by grouping. Okay, so the 3m minus 1 is the greatest common factor. It's what the m squared and the negative 3 have in common. They're both being multiplied by 3m minus 1, so we factor it out, just like they were both being multiplied by an x or something. And then everything that's not inside the parenthesis gets its own set of parentheses. And so we get two things that we set equal to 0. We get m equals 1/3 here. Then we set this one equal to 0 to get our other two solutions. So m squared equals 3, square root of both sides. M is equal to plus or minus the positive or negative square root of 3. One answer there, one answer there. Let's check ourselves. Yeah. Okay, let's jump over to 17. I think it says to solve by grouping as well. Oh, it says factor to find all solutions. So maybe we can group it, maybe we don't have to. Alright, let's first check for greatest common factor. They both have, or they all three have, something in common. Okay, so what does that look like? We can factor something out. And that thing is an x. They all have an x. So x times x squared is x cubed. X times 2x is 2x squared. And x times negative 37 is negative 37x. Okay. Alright, so now I have, in the middle there, I have a quadratic. So maybe I could factor that again. I don't think I can. So what I'm going to do is I'm going to take that quadratic, and to finish this equation, or this, to finish this equation off and find all the solutions, I know I have 1, x is equal to 0. So if I plug in a 0 for x, the whole thing becomes 0. But what about the other part? Alright, let's take that over here. And it looks like the kind of thing I would solve by completing the square. So I'm going to do that. Alright, so take b and divide it by 2, and you get 1. And then 1 squared is just 1. So that's what we add here and here. So to complete the square, we just put b divided by 2 in the parentheses is equal to 38. Now we take the square root of both sides. We have x plus 1 is equal to the positive or negative square root of 38. Okay, so can we do anything with that? Can we simplify it? I don't think so. So I've got x equals negative 1 plus or minus the square root of 38, and x equals 0. Alright, let me check that one real quick. Negative 1 plus or minus square root of 38 and 0. Yep, good for us. Okay. Okay, let's do this one, and we'll call it quits after this one. But we need a calculator for this one because it doesn't factor by grouping. You could try it, and you would see you could take out an x squared, and it would leave you with x plus 4. And then you try to do x plus 4 here, and you'd have to put a 5 there, so you get 5x, but then 5 times 4 is 20. So this doesn't factor by grouping. You could try it, or you may just recognize it ain't happening. All right, so what we're going to do is we're going to go to the calculator and we're going to plug that in and see if we can find a real zero. Since it's cubic, we know that it has at least one real zero. That's 5x plus 2. The fundamental theorem of algebra says it has 3 zeros. They don't necessarily have to be real, though. Okay, so one of these zeros here, let's see, second table. I'm going to go down and see. See which one of those is a zero for me. Oh, -1 and -2. So I can pick either one. I'm going to pick -1. Go over here. So I know that one of my zeros is x equals -1. If I want to write that as a linear factor, I could write it as x plus 1. And so then what do I multiply by to get the original function? Alright, well, I'm going to do some long division here first, just because we need to practice it. I'll also do synthetic division. But alright, so x will go in x cubed, x squared times x is x cubed, and x squared times 1 is x squared. And we subtract all of that. We get 3x squared. Bring that 5x down. How many times will x go into 3x squared? 3x times. So we get 3x squared, and then 3x times 1 is 3x. So we subtract that, and we get 2x, bring down the 2, and how many times will x go into 2x? Twice. 2x, and then plus 2, and we get a remainder of 0. So what goes in here? Nothing other than x squared plus 3x plus 2. Alright, now, let's look at that quadratic. That one looks like it will factor. What are factors of 2 that add up to 3? 2 and 1. So we have x plus 1 times x plus 1 times x plus 2. So we've got some multiplicity going on there. We've got x plus 1 squared times x plus 2 is equal to 0. So x equals -1 is a 0, and x equals -2 is a 0. And that's precisely what we see in our graph. Let's go back and look at the graph. And it's kind of fuzzy. It's kind of hard to see on this grainy picture. If we zoomed in, you could see that it actually crosses through at -2, and then it comes back down and just bounces off the x-axis right at -1. Okay. Before we call it quits on this video, you may have already called it quits, but I'm going to go ahead and do not completing the square. I'm going to go ahead and do synthetic division. Alright, so I'm going to use my -1, and then I've got all my coefficients, 1, 4, 5, and 2. And the way we do synthetic division, we bring down the 1, and then we multiply -1 times 1 and get -1, place it right below the 4, then we add that column, then we multiply again, then we add that column, then we multiply again, we add again. Oh look, got a remainder of 0, and we've got an x squared plus a 3x plus 2, and that's what we got from our long division. Okay, so same answer either way. That blue looks a lot easier, I'm sure, than the long division method, but long division is very handy. Okay, so that's number 19, and more to come later.